Okay, so we're going to talk about equilibriant forces. We want to hold an item static or stationary. The problem that we're going to be doing is we have a 50 Newton weight that's hanging straight down, and if we want to hold it steady around this center point here, if we want to hold it steady, let's say it was on a rope hanging down and we have a person A over here at 30 degrees off the x-axis to the left, and they're holding a rope, and we have person B up here at 60 degrees to the right off of the x-axis, and they're holding a rope. So what forces do they need to be pulling in order to hold this 50 Newton weight steady? So to solve a problem like this, we're going to make sure that the sum of the forces in the x direction remains zero, hold the thing stable or static, and then we want to make sure that the sum of the forces in the y direction also sum to zero. So we'll start with a sum of the forces in the x direction. This is sum of the forces in the x direction, and we want to set those equal to zero, meaning we want to hold the item stationary or static. We don't want the item to move at all. You'll see that the 50 Newton weight that's hanging down is only in the y direction, doesn't have any x component at all. So the forces to the left have to equal the forces to the right in order to hold this object steady. And that then is to say that this x component, this x portion of A, will say that A sub x should be equal to B sub x. A sub x is pulling to the left, B sub x is pulling to the right, and they have to equal each other. So what is this A sub x portion of vector A? We'll have to use the cosine theta equals adjacent over the adjacent side over the hypotenuse, because the A sub x is adjacent to this angle 30. It's the one that's right next to it. So this, if we solve for the adjacent side here, we could say that A sub x is equal to cosine of 30 times A, whatever A is. So in for A sub x now, we're going to put A cosine 30. And then in for B sub x, very similarly, the B sub x side of vector B is the adjacent side of this angle 60. So then we'll say that B cosine of 60, if these pull equally, the item, the 50 Newton weight, will remain static. If we wanted to solve this equation for B, we could do that, couldn't we? We could just divide both sides by the cosine of 60. So we would have A cosine of 30 over cosine of 60. This is actually, you can put this in your calculator and come out with a number of 1.73 times A is equal to B. So there's one of our equations. And that's as far as we can get with that. So we're going to need a second equation now. So we're going to have to sum the forces in the y direction. And when we sum the forces in the y direction, I'm trying to figure out where to put this here. I guess I'll put it right down here. We want them to equal 0, so this item will remain static or stationary as well. So the sum of the forces in the y direction, the down pull has to equal to the up pull. The down pull is only the 50 newtons, so the 50 newtons is going to have to equal to the y portion of vector B plus the y portion of vector A. And in order to find that, we'll see that the y portion of vector B is on this y portion is on the opposite side of this triangle as the 60. So to find what B sub y is, we're solving for this opposite side. So B sub y would be equal to B times the sine of 60. And to find the x component of A, the y component of A, this vertical component, A sub y is going to be A times the sine of 30. So well, our 50 newtons down has to equal to our both of the up forces, which is A sine of 30 plus B sine of 60. Now we have, again, up here we have one equation and two unknowns, and here we have another equation with two unknowns. If we were simply to say, well, shoot, let's substitute in for B, let's put this 1.73a in where we see the B down here, right? We're just going to put that right in place of it. And now we have a solvable equation. We have 50 newtons equals A sine 30. And in for B, we're going to put in 1.73 times A. And then we also have a sine of 60. So if you crunch the numbers and solve that for A, we're going to take this sine of, let's see here, this sine of 30, and this ends up being a half an A. And then we have 1.73 times the sine of 60. This ends up being a total of 1.5A. So we have, over here we have 2 A's equal to 50, and we can solve this and we can say that A is equal to 25 newtons. And that's what the person on the end of rope A is going to have to pull in order, that's his part and what's going to have to happen in order to hold this 50 newtons steady. How do we find what B is? We simply now take A and bring it up and plug it in to back into this equation here. So we have 1.73 times 25 is equal to B, and we can then say that B is equal to 43.3 newtons, and that's the portion that B has to pull.